Hi Year 10s, welcome back. Today we are doing factorising by completing the square. So it's a new method of factorising that you haven't been taught before. Just a warning in a test, if it says factorise by completing the square, you must use this method. You have to do what it tells you to do. Okay, a little bit of revision before we start. So have a look here. Actually, I'll let you write down this first board. Alright, and we'll just continue from there, and then the rest are examples, so we'll get to that in a minute. So a bit of revision, expand the perfect square. So this was from the very first exercise. Remember the shortcut rule, that you look at the first term and square it, so you get x squared. The middle term's harder. It's the first term times the second term times 2. So 5 times x is 5x, times 2 is plus 10x. Do you remember that step? And then the third step is the second term squared, 5 squared is plus 25. So that's called a perfect square, and hopefully you remember the shortcut rule. Alright, now let's do another one with a negative in the middle. So first term squared is x squared. The first times the second times 2. So it's minus 10x times, so it's minus 10x. And then the third one is the second term squared. Minus 5 squared is positive 25. Positive, do not write negative. Minus 5 times minus 5 is positive 25. So hopefully that rings a bell. That's how to expand perfect squares. You need to know that for this topic. Okay, one more little thing. Let's factorise dots. So remember dots. Something squared minus something squared. It's always a minus. Remember that? So if you wanted to put the step in, you can say x squared minus 3 squared. And then when you factorise, it's x plus 3, x minus 3. Good job, you just factorised it. Now, factorise this one. X squared plus 9. Now, a lot of people go, oh, I haven't seen this before, and they make up stuff. What was my rule that I stressed? That sign must be a negative. That is not a negative, that's a positive. So you say, cannot factorise. You cannot factorise it because that is a plus. Do not get tricked by that. They might give you that in a test. All right, so we're moving on. So have a look at these notes, everyone. You can copy down that first bit and then I'll explain it to you as well. Alright, so we're going to do completing the square. So we have to factorise this. So what we do is we start off just looking at the first two terms. So we've got x squared plus 8x. So we ignore that minus 3 for now. So we have to turn this into a perfect square. So what number needs to be at the end to be able to turn this into a perfect square? And there's a step to work that out. There's a method. We look at the coefficient of x, which is 8. You halve it and then square it. So half of 8 is 4. 4 squared is 16. So it's always a plus, so you're plus 16. Now this that we've just created, this is a perfect square. So we can factorise that in just a minute. But you cannot just add 16 to an equation for no reason. It's not a balanced equation anymore. So since we added the 16, we must also take away 16. Now it's balanced again, but we've also got a minus 3 there. That was given at the start. So you can't ignore that, so you write down a minus 3 as well. So hopefully everyone understands that. You look at the middle term, halve it and square it. So half of 8 is 4, 4 squared is 16. So we've got plus 16. That's our perfect square. And then you minus 16 as well, because you can't just add it for no reason. And we've got the minus 3. So that minus 3 comes down here. Good job, that's our first step. Now next step, x squared plus 8x plus 16. We won't even factorise it yet. We combine these, collect like terms. That's minus 19. Alright, now we can factorise. If you factorise a perfect square, hopefully you can do this shortcut rule. It's x plus 4. Remember the square of that is x. The square of 16 is 4. So it's x plus 4. And it'd be x plus 4 again. So it's x plus 4 all squared. And then we've got a minus 19 there. So this step, just for your interest, is called turning point form when we do graphs. But you don't need to know that just yet. But just in case I accidentally mention it, it's turning point form. Now we can factorise that because this is something squared minus something squared. But how do we turn that into something squared? We will change it. So x plus 4 squared minus, we can say square root 19 squared. Square root 19, and you square it, and you it equals 19 again. So hopefully you understand that 19 is the same as square root 19 and squared. So now we've got something squared minus something squared. That is called DOPS. So remember DOPS? It's the first one plus the second one in the first brackets, the first one minus the second one in the second brackets. So let me explain. So we've got x plus 4 plus root 19, and we've got x plus 4 minus root 19. And we are done. So all that work for completing the square. But once you practice it again, seriously, it's pretty easy. So, and that's how you leave it exactly like that. That's in exact form. So we'll just leave it like that. So if you want some notes on how to do it, let's write down what we did. So the first step, we needed to find this 16. So we half coefficient of x and square it. So you half the coefficient of x, so we get 4, and then square it, so you get 16. And you add that to the equation. Then step 2, you take away what you just added, and also add the other number. I won't write that in, but you've got to add that other number as well. Step 3, what did we do? We simplified, collect like terms. And then we turned it into, as long as it's a negative, remember, you can factorise. So if that's a negative, then you turn it into a square. So we'll say, step 4, we turn that 19 into square root. So I'll say turn into third squared. Hopefully you know what I'm talking about. We turn the 19 into root 19 squared. And then step 5, what do? We use DOPS. We use DOPS to factorise. Okay, so they're the 5 steps, but once you actually practice a few times, you won't even refer to that, you'll just know how to do it. Alright, let's come over here and let's do a couple more examples. So, x squared minus 6x. So your middle term is 6, you halve it, you get 3. 3 squared is 9. Always a plus, because even if you have minus 6, you get minus 3. When you square minus 3, you get positive 9. So it's always a positive there. Because we've added 9, we must take 9 away, and we've got the plus 2 there as well. We can factorise this. I'll do that in one step. Factorise this, and we get x minus 3 all squared. It's a perfect square. And minus 9 plus 2 is minus 7. That's called turning point form. Next one, x minus 3 squared. We want to turn this into something squared, so it'd be negative root 7 squared. And now we use DOPS, x minus 3 plus root 7, x minus 3 minus root 7. And we are done. Can you see, once you practice, you don't need to refer to those steps. It's just a matter of doing step by step. Each step is easy, it's just a matter of remembering. Let's do another one. X squared plus 6x minus 1. Okay, so half of 6 is 3. 3 squared is 9. We must take away 9 and take away the 1 as well. Again, we've got x plus 3 all squared, and you've got minus 10. What's our next step? We have to turn the 10 into minus root 10 squared. And then our last step is DOPS. We factorise x plus 3 plus root 10, x plus 3 minus root 10. I'll give you a chance to copy that down. Excellent. One more example and then we are done. Alright, the last one. So we go x squared minus 2x. So what number do we add to the end? Half 2 is 1, 1 squared is 1. So we add 1. What do we do? Because we've added 1, we must take 1 away, and we've got the plus 8 as well. So we've done this step a few times. Now we factorise, turn this into a perfect square. So we've got x minus 1 all squared is a perfect square for those 3 terms. And now we combine these two. Plus 8 minus 1 is plus 7. Now, if you don't listen in class, you'll probably say, turn that into root 7 squared, and you'll continue. But what do we say right at the start? Must be a negative. Since that's a positive, what do you say? You stop right there and say, cannot be factorised. It can't be factorised because that is a positive. So remember, right from the start, when we said, it was over here, x squared plus 9, you cannot factorise it. It's exactly the same as what we just had just then. So that is it, everyone. So the homework is right down here, so we'll go back over here. Exercise 5E, 1 to 4 every second, 6 every second, and try 8 and 9. They're problem-solving questions. And don't forget, smash that like button.